Okay, so we're going to review and do some problems just with logarithms. So what we're going to focus on is going from here, okay, to here, okay? And I want to make sure that I go back and do this because we've got it going the one way. We really need to work on being able to go backwards. Okay, so I think we have it the one way we're going to try. So let's start out with some easy ones. Are you ready? So this is still 6.6. So logs to exponents. Okay, so here we go. I'm going to start out real basic. We'll do one of these. Okay. All right, so wonder if you get a log on each side. So just like we would have solved if we had a power on each side, if you have a log on each side, guess what you can do? You can get rid of them. All right, so you're left with 7x minus 3 equals 2x plus 17. All right, minus 2x. I get 5x minus 3 equals 17, add 3. I get 5x is equal to 20 and x is 4. Okay. How about something simple like this? Log 3, 2x plus 9. So just like, remember how we isolated, remember how, hold on. So remember we were doing these problems in class, and I'll find one. Okay, like this one, okay? Remember how we were looking at like, oh, I need to isolate this piece, so I need to add 5 first, okay? So that literally all I have on one side is the 2 to the third piece. Well, guess what? You need to do the same thing with this. Do I have a log? Do I have this 8 piece? Do I have this isolated? Is this piece isolated? If it doesn't matter on this side, but do you have this stuff isolated? And if you do, you can go ahead and go from a log to an exponent. Well, what's our base? My base is 3. Where do I get my power from? Oh, the other side. So this is 3 to the third equals 2x plus 9. Well, what's 3 to the third? That's 27. Okay, subtract 9, I get 18 equals 2x divided by 2, and x is 9. Okay, the only thing you really got to watch on these is if I plug 9 back in, do I get a positive number here? Oh, I do. So because if you get a negative number, you might have an extraneous solution. All right, let's try another one like that. Let's do it with log 4, 10x plus 624 equals 5. Okay, all right. I have a small number, I have this, I'm good to go. All right, what's my base? What would be if I highlighted my base, which is the same as the 2, right? Where's my 2? Right there, right? So 4 to the 5th power. The 5th power is, okay, that red part, and then equals to 10x plus 624. Okay, 4 to the 5th power, yikes. That's a big number, yikes. I better get I don't know if I have a calculator out. Well, let's see. It'd be 256 times 4, carry the 2 would be 22, carry the 2 would be 10. 24 equals 2x plus 624. Okay, and so now I'm going to take 1024, I'm going to subtract 624. Okay, 1024 minus 624 is 400. Divide by 10, and x is 40. Okay, if I plug in 40, do I get positive or negative? I get a positive, so life is good. Okay, let's do one real quick. Let's do one with an, oh jinkies, let's do one with an ln, with just a plain Jane ln, because I'm a little concerned. I want to make sure that we're going to get that. So let's do this one. ln x plus 7 equals 4. And I don't mind doing that in this tiny amount of space because it's really not that hard. Okay, the nice thing is, okay, if I have an ln, that's an e, right? Okay, so if you wanted, you could put a little e here because that's really, it would be an e, okay? So I have my p, I really should just have an ln and then this piece. Okay, so here I am. My base is e to the 4th power equals x plus 7. E to the 4th power you do on your calculator. I would if I could find mine. Haha, I found it. Here we go. Okay, so second function, e to the 4th power, remember that's 2.7 something something, 54.6. But you know what? I'm going to leave that on my calculator because I'm going to try not to round. What am I going to do with that 7? Right, I'm going to subtract it. So I'm going to minus 7. And I end up with 47.598, which is 47.6. Is that okay? Yeah, it's okay. Okay, this is the most complicated part of this. And it's really not that bad, okay? You have to remember that stuff that we talked about with condensing and expanding. So I'm gonna give you this problem here. And there was a few problems like this on the homework, which we will definitely go over. Okay, now I want you to understand that this is different than this, okay? If it was just log on this side, log on that side, you would be good to go. But because there's 2 logs here and there's none here, this isn't going to work. In fact, this plus actually means something a little bit different, doesn't it? That plus actually means that there's something going on in between these. Do you remember what that something was? Oh, my markers are running out. Sad face. Okay. That plus, so does that mean, so there's 3 things, okay? Does it mean product? Does it mean quotient? Does it mean power? Oh, that's right, that's the product. So I wanna take, and I'm gonna put these 2 pieces back together. So I wanna take log 6, and I wanna take and multiply x minus 9 times x equal to 2. All right, so what's x times x? Well, that's x squared. What's x times 9? Well, that's 9x. Okay, so see how I have a log, I have a number, and I have this piece. Okay, now it's time to go from a log to an exponent. Here we go. 6 to the 2nd power equals x squared minus 9x. Now, friends, you know if there's an x squared and an x, you're going to have to do what? Yep, you're right. You're going to have to factor. So minus 36, minus 36. 0 equals x squared minus 9x minus 36. Okay, parentheses. X plus minus. All right, here we go. Factors of 36. Subtract to give you 9. Oh, yep, 12 and 3. So I'm left with, this isn't really a positive 3, it's really a negative 3. This isn't a negative 12, it's a positive 12. Now go back and check. Do those two work? Well, 12's okay. How about negative 3 though? If you go and plug in a negative 3 here, you will get an error on your calculator. So even though you got that answer, only 12 is going to actually work. Okay? Let's try a few more. Okay, I'm gonna switch it up on you a little bit, okay? So don't panic. I want you to really look at it for a second. Okay, now look at that. What's the rule? If I have a log on each side, what can I do? Do I have any other numbers? Or am I good? I can cross those out, right? Just like if it was exponents, right? Okay, let's solve for x. So get this x over on this side. So I get 4x is equal to 4 and x is 1. Am I good? Any negatives? Nope, I'm good. Okay. All right, how about this one? Okay, can I just cross everything out? No, because there's not natural logs all the way across. Okay, well, there's a natural log here, natural. Does this minus mean something different? Means I can't use that highlighter. Okay, that minus, actually, it's not a product, it's actually a quotient. So, quotient means division. Okay, that looks really weird. But you know what? It's not a big deal. Okay, you can totally do this. All right, do I have my natural log and my number? Yes. Okay, it's time to go from this to this. Now my base is what when it's natural log? You're right, it's an E. So where do I pick up my power? From across the equal sign equals 3x over 2. Well, e to the 4th is 54.59. Okay, what am I going to do with this 3 over 2? Well, I'm going to multiply by 2, right? And divide by 3. 36.4. So this was what? 54.6 equals 3 multiplied by 2, and I end up with 36.4. And that's okay. So see, it's really not that bad. You can handle going back and forth. Let's do one more just for kicks and giggles. Okay, let's do another one where you have to factor, shall we? Okay, that's a good one to practice. Let's see, I know we did one already on your, homework where you did that. Let me go back. How about this one? How about this one? Well, you know what? I'm going to go easy on you. Log 6, 3x plus log 6, x minus 1 equals 3. Okay? All right, could I cross out logs? Oh, no, this one doesn't have a log. All right, that means that this plus must mean something. It means it's a product. So log 6, 3x times x minus 1 equals 3. All right, here we go. 6 to the third power equals, okay, what's 3x times x? 3x squared. What's 3x times 1? 3x. Okay. 6 cubed. 6 times 6 is 36. So 6 to the third is 216 equals 3x squared minus 3x minus 216. Okay, because I want it set equal to 0. All right. You know, I could do the Cole-Brooklyn method, but I wonder if 216 is divisible by 3. Because oh, it is. Whew-wee. So divide everybody by 3. Divide by 3, divide by 3, divide by 3. So 0 is equal to x squared minus x minus 72. Whew, a lot easier, isn't it? All right, let's factor x plus, x minus. Factors of 72 that subtract to give you 1. Yep, 9 and 8. But this really isn't a positive 8, it's a negative 8. And this isn't a negative 9, it's a positive 9. Now, when you go back up, who doesn't work? You're right, the negative 8. Now be careful. Not every time that you get a negative might the negative not work. So you just need to check it back. So negative 8 times that would give me a negative number. And look, I can't do, if I plug in log, okay, 6, and then up here, 3 times 8 would be negative 24. Look what happens. Non-real answer, okay? So good job, and we'll practice this more tomorrow.